This is NIS310, building a global connected network using Direct Connect SiteLink. My name is Sid. I'm a Principal Solutions Architect with AWS. I've been with AWS for over 8 years, and I'm excited to be talking to you guys about Direct Connect SiteLink today. Now, to set the context on why we are here, the primary reason is because traditional enterprises are complex. Now, most of you work for organizations that have some kind of on-premises equipment in data centers or warehouse factories. And if any one of you don't have any on-premises infrastructure, then you're at the wrong session, because we are going to talk about hybrid connectivity quite a bit in this session, which means basically connecting your on-premises sites to AWS in a secure manner. Now, depending upon what kind of industry you are in, you might have warehouses, you might have smart factories. With that in mind, we see 88% of enterprises have a cloud-first strategy, which means for any new applications which you're deploying, they're leveraging the cloud. That being said, 86% of infrastructure spend is still on premises. Basically, what this means is there is a need to connect your on-premises infrastructure with AWS. So the vision here is that AWS becomes the hub to which you can connect all your on-premises infrastructure. You host your applications in AWS. So now your data centers can access applications hosted inside AWS. Your smart factories, smart cars, IoT devices can send data to AWS. Not only that, AWS can become a bridge to connect your infrastructure together. So if your smart devices, your factories want connectivity back to your data centers, then AWS can help with that as well. And this is what we'll be talking about in today's session. We'll see how we can achieve this networking vision while being secure. Now, the fundamental piece of this vision is the AWS Global Infrastructure, which powers everything. This consists of regions, AZs, and POPs. Now, for those of you who are relatively new to AWS, regions are large geographic boundaries where we cluster our data centers. Availability zones are isolated sections within those regions with redundant power, network connectivity. It's mainly for fault tolerant and isolation. And then we have our edge locations for low latency access of data to your end users. Those are our points of presence used by services like CloudFront, Global Accelerator, etc. All of this global infrastructure is connected by redundant 100 gigabit Ethernet networks. And finally, for you to connect to this global backbone, we have a service called AWS Direct Connect. And we'll be spending quite a bit of time understanding what that service is and how you can use it. So let's jump right into it. What is Direct Connect? Direct Connect is a way for you to bypass the internet and set up dedicated direct connectivity to AWS. The whole idea here is that by bypassing the public internet, you are getting more consistent performance and avoiding the internet bad weather. It's a security conference, so we have to talk about security. So all the data which you're sending via Direct Connect is encrypted. We'll talk about MACsec in more detail on how it works and how you can use it. But MACsec is the protocol at layer 2 MAC level, which lets you encrypt your data between your devices and AWS. You have a lot of flexibility in what kind of circuits you get to AWS. You can go as large as 100 gigs per second, where you can set up dedicated circuits, which is dedicated for your connectivity to AWS. Or you can work with one of our partners and get a hosted network, where you don't deploy dedicated circuits to AWS, but rather the vendor or AWS partner leases their circuits or a part of their circuits to you. And then you can go as low as 50 megs per second. It's great for if you're just getting started. You also save costs. With AWS Direct Connect, your data transfer out charges reduce drastically. Your data transfer in is absolutely free, and you get pay-as-you-go pricing. So if you decide to decommission Direct Connect, you don't pay for it anymore. To get started, you connect physically to us through a Direct Connect points of presence. This Direct Connect points of presence or Direct Connect locations are third-party co-location facilities. This is like Equinix CoreSite, where AWS has presence. We have over 100 of those worldwide. Let's look at an architectural diagram to understand how it works. On the left, you have the AWS global network. On the right, you have the corporate data center. Now, our requirement here is to connect them securely. So firstly, you'll decide on AWS Direct Connect location. This is one of the third-party colo facilities which is nearest to your corporate data center. Then you go ahead and request a connection from AWS. Between the AWS Direct Connect location and the AWS region, we have AWS Global Backbone for connectivity. You'll go ahead, work with a third-party vendor, your service provider, or an AWS partner to set up last-mile circuit between your data center and a cage within this third-party colo facility. This is what we call the last-mile circuit. Once this is done, all we need to do is connect the AWS device to your device. For that, we can set up a cross-connect. Now, once this is done, we have end-to-end connectivity between your data center and AWS. Now, it's a similar diagram as we saw before. On the right, you have your customer data center. You're connecting via a Direct Connect location. In the AWS cage, we have the AWS device connected to the cloud. Now, let's talk about MACsec. What is MACsec? Now, MACsec is an encryption protocol which encrypts data at a link level. So it's an Ethernet-based MAC security protocol. When you set up MACsec, you're encrypting the link between your cage and AWS, and your device and the AWS device. This is layer 2 encryption. This is wire level encryption, so you don't really have to pay for any performance like you have to do with IPsec or any kind of encryption protocol on the top. You can also set up MACsec between AWS device back all the way to your customer data center. This is a common setup when you're using something like VPLS, where a provider is setting up Metro Ethernet for you. So they are doing a layer 2 extension all the way back to your data center, in that scenario, the MACsec is all the way back to your data center from the AWS device. Now keep in mind that there is a partner device which is in the colo facility, but it's sort of transparent because they're doing a layer 2 pass-through of all the traffic, including the MACsec PDUs. MACsec support is available for 10 gigs and 100 gigabit Ethernet at select Direct Connect locations. Now, our encryption story doesn't end there. Within AWS, between our AWS facilities, there is also encryption. There is optical or MACsec encryption, which is managed by AWS. So you don't have to enable or disable anything. This is there by default. So between our data centers within a region and also across region, we have this encryption enabled by default. Now within an AWS region, within your VPCs, when you create EC2 instances, if you're using one of the latest generation EC2 instances, the Nitro instances, an example here is the C5N instances, traffic between those instances are also encrypted by default. Now on the bottom you see there's a C5N and a C4 instance. That traffic is not encrypted because C4 is an older generation instance and does not have the same functionality. Now if you bring in other components of your network architecture which you would probably use, like VPC peering, transit gateway peering, you'll see that all of that traffic is also encrypted. Now let's bring our Direct Connect location in. The traffic between the AWS device and the AWS region is also encrypted. And finally, your router and AWS router or AWS device are connected via Direct Connect connection where you can enable MACsec. Everything is encrypted on wire. And we have not even talked about TLS or IPsec or any of those additional protocols which you can use to encrypt traffic further. So we have wire rate line encryption. Okay, awesome. So now we understand how Direct Connect works. We understand when you create connections, there is encryption. But encryption is not the only thing which is important. Let's talk about resiliency and high availability. If you're using Direct Connect to connect resilient production-grade workloads from your on-prem to AWS, you need resiliency. You don't want single points of failure. So we recommend connecting via at least 2 Direct Connect locations. And on your side, we also recommend, if you have multiple data centers, then establish that connectivity to separate devices in different data centers. For maximum resiliency, this is the recommended model. Here we have 2 Direct Connect connections in 2 different Direct Connect locations. So we have 4 circuits. Now, in this case, even if a router in a location dies, or if an entire location is down, you still have connectivity from AWS to your on-prem. Our Direct Connect availability and resiliency models are backed by SLA. So you get 99.99 for a total of 4 connections. That's the previous diagram which we saw. And you get 3 nines if you're using 2 locations and 1 connection per location. The QR code on the right takes you to our AWS Direct Connect SLA page, so you can read more there. To get started, you can also use AWS Direct Connect Resiliency Toolkit. When you're using the toolkit, it automatically asks you what kind of resiliency posture you want to be in, and automatically provisions the required number of circuits. If you're using Direct Connect for dev test workloads, we still recommend having something like VPN for a backup in case your Direct Connect connections go into maintenance, which is a common thing. So keep that in mind. So up till now, we looked at how the physical connectivity works. We haven't seen how you access your AWS resources like your EC2 instance, VPCs, S3, DynamoDB using this physical connectivity. Let's talk about that. So in order to get started with that, you need to create a Direct Connect gateway. You'll go into an AWS account, use AWS Console or CLI and create this Direct Connect gateway. This Direct Connect gateway is a globally distributed logical AWS resource. Later in the presentation, we'll dive a lot more detail what AWS Direct Connect gateway is and how it works. But for now, understand that it's a global resource which lets you connect to multiple AWS regions. In this case, we have created a transit VIF. When you create a VIF, you're creating a BGP connection between your router and the Direct Connect gateway. And using that connection, you can access AWS resources. In this example, transit gateways in AP Southeast 1 and US East 1. A Direct Connect gateway can connect to up to 3 transit gateways globally. You have other options of connectivity. You can use a private VIF. With a private VIF, you get connectivity to a VPC. So there's no transit gateway involved. And there's a third kind of a VIF called the public VIF, where you get connectivity to AWS resources that sit outside the VPC. So these are Amazon S3, DynamoDB. These services are addressed by public IP addresses. So this public VIF allows you to access resources which have public IPs owned by AWS. Okay, so we know Direct Connect is awesome. I hope I did a good job of convincing you that Direct Connect is awesome. But there's more to connectivity. We hear a lot from customers. We hear a lot from customers that operating global private networks is problematic, is a challenge. Now, this is where you have to connect your data centers to each other. So let's say you're operating data centers, warehouses, factories, whatever it might be in Europe, in US, Singapore, Asia, and you want to connect all of them together. You have to work with different service providers. You have to get into long-term contracts, which can be really expensive. Scaling up and down is not easy. Maintaining security, etc., gets even more difficult. So we had an idea. We have this global backbone where we have terabits of capacity across the globe. Why not we make it available to our customers so they can connect their data centers together using our backbone? And that's exactly what we did with AWS Direct Connect SiteLink. It lets you take your Direct Connect connectivity and extend it so that you can use it with your own on-premises locations. So the idea here is you have corporate data centers all across the world. You create last mile connectivity to the nearest Direct Connect location. From there, AWS takes over. Powered by Direct Connect Gateway, now you can route between any of your data centers to any of your data centers. All you need to do is send the traffic to Direct Connect location down to Direct Connect Gateway, and the Direct Connect Gateway is going to pick up your traffic from a Direct Connect location, let's say in Asia Pacific, and route it all the way to a Direct Connect location in North Virginia, United States, and all of that is going through the AWS backbone. It is available all around the world in all AWS commercial regions, except in China. Okay, let's dive a little deep into how this works. So I have an architectural diagram here, very similar to what we saw before. On the right, corporate data center. In the middle, we have a Direct Connect location. And on the left, we have the AWS cloud with regions, VPCs, etc. Now, before SiteLink, if you tried to send traffic between Direct Connect locations, that would not be allowed because this was not something which we supported. Now, post SiteLink, all we did was we configured our backbone to allow this traffic flow. So now you can send traffic to a Direct Connect location with a destination IP of your own corporate data center, and the traffic will be routed back to the Direct Connect location, back to your corporate data center. In fact, why do we even need AWS region here? Why, you don't really need any VPCs, you don't really need transit gateways, etc. for this to work. You can be a brand new customer of AWS, just go and provision a Direct Connect gateway, establish Direct Connect circuits, and you can use AWS to route your traffic without having any AWS resources, no EC2 instances, no S3 buckets, no commitments required. Now, for some of the advanced users, I'm sure there are one or two here who say, hey, even before SiteLink was enabled, I was using transit gateway to route my traffic globally. Should I switch to SiteLink? Let's see what an architecture looks like if you were not using SiteLink and relying on transit gateways to route traffic. So this is what it looks like. From your customer data center, you're sending traffic to a Direct Connect gateway up to a transit gateway, which is sitting inside an AWS region. That transit gateway, using cross-region transit peering, sends traffic to a remote region in EU West 2. Then that transit gateway sends the traffic back down to Direct Connect, back to your data center. Now this architecture works, but there's a lot of disadvantages. First, it costs a lot more. You're paying for 2 transit gateways. You're paying for data processing charges on those transit gateways. Secondly, there's added latency, where you're sending traffic to multiple hops. And in this case, you have 2 additional transit gateways the traffic is going through. And then finally, you have regional dependency here. So if AP Southeast 2 or EU West 2 has some kind of a failure, then you lose your hybrid connectivity as well. We want to avoid that and move to a SiteLink model, where the entire AWS regional infrastructure goes away, and the traffic between your data centers is routed over our AWS border network, and it takes the shortest path. You don't really need to pay for transit gateways. All you need to pay for is data transfer charges over Direct Connect. And we'll talk about pricing in a bit. So it's much cheaper. It's much faster. You don't have any regional dependency. Even if AP Southeast 1 and EU West 2 fails, no problem. As long as our border network is up and active, you'll be able to send traffic. To enable SiteLink, all you need to do is create 2 virtual interfaces and attach them to the same Direct Connect gateway. Now, in order to do that, you can use the AWS console. So here you can see on the left, you have an option when you create a new VIF. There's a simple checkbox, a flag, which says Enable SiteLink. And on the right, you can edit an existing virtual interface. If you already have Direct Connect circuits, you already have connectivity, you want to enable SiteLink, just go edit, check the box, and you're done. You can do the same with any kind of command-based interface. So if you're using CLI, CloudFormation, SDK, etc., you can do the same. It's basically a flag which you need to enable. So let's recap what we learned about Direct Connect SiteLink. Direct Connect SiteLink lets you send traffic over the AWS global backbone, taking the shortest path. Turning SiteLink on and off takes minutes. You can create any-to-any connections, so you can send traffic from anywhere in the world. All Direct Connect locations, POPs, are supported except China. And finally, you can turn on and off in minutes using the same tools and software objects as you do today, because it's part of the Direct Connect service. It's not a brand new service. So any tools which you currently use with Direct Connect supports SiteLink as well. So now we have a good understanding of what Direct Connect is, and we also understand how SiteLink works. Now I'm going to dive a little deeper into some of the use cases, routing, etc. So I'm going to try and slow down. so that we can spend ample time on some of the advanced stuff here. So the most simple use case which we see with customers is a full mesh connectivity. This is where you connect any data center to any data center. This is pretty much what we have been talking about today. In this example, you create VIFs connected to a single Direct Connect gateway, and once you do that and you enable the SiteLink flag, you can route between any of your corporate data centers. But we are in a security conference and we like isolating stuff. So let's talk about isolated connectivity. So I have two examples here to show how this is done. In this example, the first example, we have a customer data center. As an enterprise, you're trying to connect to two different partners. Now your security requirement says that you don't want to share your circuits, or you want to create some kind of level of isolation in your connectivity to each partner. So for that, to get started, number one, you have your customer data centers connect to the nearest Direct Connect location, and you have your partners do that as well. Now we live in a world where everybody is moving to a cloud vendor, and there's a very high chance that any enterprise company you want to connect with or any partner you want to connect with already have and has connectivity to AWS. So let's leverage that connectivity to gain access to their infrastructure as well. For isolated connectivity, we'll create two Direct Connect gateways. Next, we'll create two virtual interfaces. One interface per Direct Connect gateway. Now, as I said previously, when you create a virtual interface, you create a BGP session with that router, with Direct Connect gateway, and all the traffic which you send is tunneled in a VLAN. So the traffic between your router and AWS for these two connectivities are isolated within their own VLANs. They have separate routing controls as well. You share the Direct Connect gateways with your partners, your vendors, your other enterprises you're trying to connect with, and have them connect to those Direct Connect gateways. So what we ended up with here is, from your customer data center, VLAN red goes to Direct Connect gateway 1, goes to partner 1. That's completely isolated. And then for partner 2, your customer router, to the purple VLAN to Direct Connect gateway 2 to partner 2. Right? So basically, we're using two different Direct Connect gateways, two different VIFs, two different VLANs, two different BGP sessions to connect to two different partners. I put a disclaimer on the top right which says always use multiple Direct Connect connections for high availability. I was getting these slides reviewed and they said, hey, we want to put best practices in front of our customers. So keep in mind that in this slide, I'm using just one circuit, one connection to connect into AWS, but for high availability, it is recommended to have at least two. This is a second example where I'm not connecting to any partners, but I'm connecting my two corporate data centers where I have two different environments. So I have prod and non-prod. Purple or pink or red, however you interpret that color, is prod, and then the green is non-prod. So same thing, connect to the nearest Direct Connect location, create two different Direct Connect gateways. Now you create two different VIFs, two different VLANs, but now you're using both the Direct Connect gateways for your own connectivity. One for prod and one for non-prod. So for prod, from our prod environment, the red environment is probably a VLAN to a VRF in your router, then to a VLAN to AWS, a BGP session to Direct Connect gateway 1, down to the same VLAN back to your other router, back to a VRF, back to your own isolated prod environment. Right? So the traffic gets completely isolated end-to-end, and the same for the non-prod environment. Now, if you had your own AWS infrastructure, that's basically VPCs, you can have prod VPCs, non-prod VPCs, you can extend this isolation into your VPCs. It's very simple. All you need to do is connect your prod VPCs to prod Direct Connect gateway and non-prod VPCs to non-prod Direct Connect gateway. And now this isolation which you establish between your data centers gets extended into the AWS region. So we have prod network and a non-prod network. Now you can create more if you want. Direct Connect supports up to 30 virtual interfaces, so you can have 30 of such isolated environments. Let's talk about pricing. There are two pricing dimensions for SiteLink. This is over what you pay for Direct Connect. There is a per hour cost. So when you enable SiteLink on a WIF, you start paying for that per hour cost. That's a flat fee. But there is a variable fee as well, which is the data transfer fees. And this varies based on where you're sending traffic from and to. We have 10 different source destination groupings based on geography. For example, Europe, US, Middle East, Australia. So there's a cost of sending data from Europe to US, which will be different from the cost to send traffic from, let's say, Europe to Australia. It's purely based on distance. The more we have to take the traffic on our backbone, the more we charge. It's a very simple pay-as-you-go pricing. We want to keep it transparent. This is the pricing page. We obviously keep fluctuating our pricing, trying to keep it down, trying to pass savings to you guys. So always check the documentation for the latest or what the pricing is. Let's talk about some frequently asked questions. IPv6 support. It is supported. Both IPv4 and IPv6 is supported over SiteLink. There are some quotas related to Direct Connect. The same quotas apply to using SiteLink for your on-prem connectivity. The main ones to keep in mind is when you create a Direct Connect gateway, you can connect it to up to 10 VPCs, 3 transit gateways. You can create 30 private WIFs, 1 transit WIF. And in addition, you can advertise 100 BGP prefixes over a virtual interface. The only unique thing about SiteLink is because SiteLink is connecting to all your on-premises sites and learning the routes which you're advertising, so these 100 prefixes from all the different customer locations, it's going to take all of those routes and re-advertise those routes back to your data center. QoS, if you are using QoS today for connectivity between your data centers for prioritizing traffic, you can continue to use that. The AWS backbone doesn't really have a concept of QoS, at least not something which we expose to our customers. So you can continue to mark your packets using DSCP, and we're going to preserve them. And as soon as we send the traffic to your router and your router gets it, you can act upon that DSCP marking and continue to QoS your traffic as it's heading back down into your network. How do I encrypt my traffic using SiteLink? So the same encryption concepts which we talked about previously with Direct Connect applies to SiteLink as well. So from the AWS Direct Connect location to the AWS cloud, we have the AWS backbone encryption. I talked about that. Between any AWS sites, AWS encrypts using MACsec and optical encryption. Between AWS and your customer router, we have MACsec, which you can enable and use. And then between your own routers, we are assuming you have some kind of a customer managed encryption, like a MACsec equivalent, which you are using. So using this line level encryption, you can get end-to-end encryption using SiteLink as well. This is an interesting one. How do I firewall traffic between customer data centers? Now, if you were not using SiteLink, and if you were relying on transit gateway prior to SiteLink for cross-region traffic, this is what it would look like. You would set up firewalls within AWS. This can be AWS Network Firewall. This can be any third-party firewall, Palo Alto, Checkpoint. Take any vendor firewall, put them in a separate VPC, call it a security VPC, firewall VPC, whatever it might be. And then the traffic flow looks like this. You send traffic from your customer router all the way to transit gateway. Transit gateway sends the traffic to the firewall. The firewall sends it back to transit gateway. It's sent cross-region. The same flow repeats to the firewall and back, and then down to your corporate data center. Right. Now, with Direct Connect SiteLink, we saw previously, there is no transit gateway. Traffic is sent between the Direct Connect locations using the shortest path over a border network. It doesn't even get into the region. So there's no architecture where you would set up firewalls in AWS. So with SiteLink, your firewalls need to be on-prem. Now you're connecting your on-prem data centers, so you probably have some infrastructure on-prem. If you have an existing firewall, you can continue to use that. Most corporate data centers have some kind of a perimeter firewall, so you can use that and use that to firewall traffic between data centers. If you don't have any kind of perimeter firewall, or you have like factories or really small offices where you don't have space to put any new hardware, then you can lease space in these Direct Connect locations and put customer firewalls there. We have also seen customers go with an option like this. Okay, finally, how do I influence routing behavior? So we're talking about active-active connections or active standby connections, load balancing across multiple links. So let's jump into this. So let's talk about routing and forwarding behavior when using SiteLink. Now, in order to understand how routing and forwarding works, we need to understand what's an AWS logical device. Now, I haven't talked about ALD or AWS logical device up till now. What we have talked about is Direct Connect Gateway. So when your routers set up a BGP peering relationship, they do it with Direct Connect Gateway. And that's what you sort of logically see when you're configuring stuff. In most AWS architectural diagrams, you'll see your your private WIF or your WIFs set up between your router and Direct Connect Gateway. But the truth is, behind Direct Connect Gateway are these ALDs, or AWS logical devices. So at each Direct Connect location, you're setting up a BGP peering with a different ALD behind the scenes. It looks like it's a Direct Connect Gateway, but behind the scenes is different ALDs which make up this Direct Connect Gateway. Now keep in mind that this device, this ALD, can be different from the physical device where the circuit gets terminated. So your physical termination might be on a AWS switch, and this ALD sits behind it. It can be on a completely different device. Right? So looking at this diagram, it's quite obvious. It feels obvious that, hey, it's ALD is where my circuit is terminating, but it might not be the case. All the ALDs, part of the Direct Connect Gateway, are connected in full mesh, which basically means that if ALD1 has to send traffic to ALD3, it does not go via ALD2. Everything is in a full mesh. These ALDs are under your account isolation. So these are not shared devices. These logical devices are created for each and every customer, in fact, each and every account, because for us, an account is an isolation boundary by itself. So Direct Connect Gateway as well as ALDs are something which is isolated within your accounts and not shared with other customers. Now, if you go into the AWS console and look at a virtual interface, you'll see on the right corner there, it says AWS logical device. Right? That's how you can figure out what the AWS logical device is. You can also do the same if you describe a WIF using a CLI or any kind of a command line interface. Now, why is ALD and knowledge of it important? That's when routing becomes interesting. So here we have a situation where you are connecting from your two data centers to a Direct Connect location, and both of them land on the same AWS logical device. Now this is a rare setup, and hopefully nobody gets into this scenario, because now you have a single point of failure for two of your circuits, for two of your data centers, and this goes against our resiliency principles. But I wanted to explain a point here, that's why I included this architecture. So let's talk about BGP. So when you set up a BGP connection, you're going to send some routes to the AWS logical device. If you guys are familiar with networking, you know when routes are being sent, there's a AS number which gets attached to the route and the actual prefix. So here your customer router in data center A is sending prefix 10.1 with the AS path 64512. The AWS logical device is going to accept that and send that back down to customer data center B. But you'll see that it appends its own AS. So your customer data center B knows that in order to reach 10.1, I need to go through 65.0.0.1 and then 654.1.2. 64512. The same on the other side, customer data center B sends a prefix, and logical device is going to prepend its ASN and send it back down to your customer data center A. This is how routing works, fairly simple. Now, if you were connecting to two different direct connect locations, which would be the recommended option, in that case, customer data center A sends the prefix. The prefix which it gets in data center B has two AS numbers, right? Because there are two logical devices in its path, right? So when you're receiving the prefixes, you can see whether it's a single ALD or you have multiple ALDs in its path. The same on the other way around. Customer B's routes, customer data center B's routes when received at customer data center A has two AS numbers prepended. Now beware of routing loops. So if you're using the same AS number on both of your data centers, then this is what's going to happen. You're going to send the traffic, the prefix to AWS Direct Connect gateway. The logical devices behind it are going to accept it and send the route back down. You're going to see that customer data center B has an ASN of 64512, and it receives a route which has 64512 in its path. BGP routing, I would say routing loop prevention mechanism says, if I get a route advertisement which has an AS number of my own, then I'm going to drop it. So in this case, the router will drop the BGP advertisement saying, hey, there's a loop, I detected a loop. And you don't want that, right? So the recommendation is either use unique ASNs. So use 65412 for one of your data centers and maybe 64513. Or you can override this BGP loop prevention mechanism by using neighbor IP address allow as in parameter. Now obviously be mindful that the BGP loop prevention exists for a reason. And if you're overriding it, you should be very careful and know what you're doing. Let's talk about a multi-path scenario. Multi-path scenario basically means that, let's say you have customer data center 1 wants to send a data traffic, a data packet to 10.1.0.5. It's going to send the packet to ALD1. Now your customer data center 2 and 3 are advertising the same prefix to AWS Direct Connect gateway and all the ALDs behind it. So in this case, where do you think the ALD1 will send traffic to? It sees 10.1.0.5 is reachable via CE2. It's also reachable via CE3, and it's also reachable via CE4. So I can send the traffic to CE2, I can send the traffic to ALD2, which will send it to CE3, and I can send the traffic to ALD3, which can send it to CE4, right? So the question is, where does the packet go? Now in order to understand, I wrote a few rules, so we'll go through that. So an ALD would prefer a path from a directly connected router over a path from a remote ALD. Now the reason behind that is BGP's path selection protocol. We're not doing anything unique here. This is not proprietary AWS logic. It's basically using BGP's path selection algorithm. We will always choose the shortest AS path, right? Assuming you have not done any kinds of fancy prepends or community tags, stuff like that, by default, shortest path will be chosen. So in this case, the traffic is sent from ALD1 all the way down to CE2. Why? Because CE2 is a single hop. CE3, CE4 are two hops because it needs to send traffic to ALD2 and then CE3, and in that case, and the other case, ALD3 and CE4. So those are two hops. CE2 is single hop, so it sends the traffic to CE2. Let's get rid of CE2. Well, that directly connected link. Now what? Now where does the traffic go? So the traffic goes to ALD1. Will it send it to ALD2 or ALD3? That's where rule number 2 comes in, where it says if you don't have a directly connected CE, which means there's no shortest path there, then it's going to install routes from all the remote ALDs. Why? Because all of them are equally distant. And it's going to do BGP ECMP equal cost multipath. The load balancing happens per flow, so a 5-tuple hash. And it's going to advertise the same prefix, or basically it's going to do this load balance irrespective of geographical location. So in this case, it's going to load balance the traffic to the data centers in Sydney as well as New York. So it's not going to say, hey, Sydney is closer, let me just send traffic there, or oh, let's send traffic to New York. It's just going to load balance. So you see one traffic for 10105 to port 876 goes to the Sydney data center, while another packet with a different port, because we're doing a 5-tuple hash, can end up to the New York data center, right? So it's globally load balancing your traffic. Now you may or may not want this to happen. If you don't want it to happen, then you can influence the traffic. That's where BGP communities or AS prepend comes in. So if you influence the traffic flow to your CE routers by tagging the routes by BGP communities or AS prepend, then we're going to honor those. Now keep in mind that when you have BGP communities tagged to your routes, you are influencing the local preference of the AWS ALDs. And that is important. We'll see in a bit why. So in this case, what I do is I tag the routes from Sydney data center with a BGP community 7300 saying it's high preference. So when the traffic is sent to ALD1, it sees, hey, the path via ALD2 and CE2 is high preference. It's tagged high preference, so I'm going to send the traffic there. And it sends it to ALD2. Now you can also achieve this by using AS prepends. In this case, when CE3 is advertising route to ALD3, it tags its routes by 2 ASNs. Basically, when ALD1 receives those routes, it's going to see, to reach CE2, it's 2 paths. To reach CE3, it's 3 paths. Why? Because 2 ASNs have been appended. So it makes the shortest path first decision and sends the traffic to CE2. Now let's make this interesting. In this case, let's bring back a connected router. So now we have the connected router and we have the ALDs. This is the same setup which we had in the first diagram when we started talking about routing behaviors. Let's add a community to CE3. Now in this case, what do you think is going to happen? I have a hint on the top. It basically says BGP best path algorithm, best path selection algorithm always prefers local preference over shortest AS path. And I said, when you tag your routes with BGP communities, you are influencing the local preference. And that parameter always takes priority. So even though CE2 has the shortest AS path, why? Because it's directly connected, and paths to CE3 and CE4 are via another ALD, so it's a longer path. It's still going to prefer the route to CE3 because of the tag community. So always keep that in mind. Let's take another example here. Here I'm doing a huge prepend, making the route via CE4 really large with 1, 2, 3, 4 hops from ALD1. But I'm tagging the community. And this basically is just to prove a point that community always takes preference. So the traffic is sent to CE4. Now let's get rid of CE4. Right? Let's say there was a failure and the CE4 route is down. And in this case, you have just CE2 and CE3 left. But CE2 has 2 AS paths. Now in this case, what do you think will happen? It's going to load balance the traffic. Why? Because for ALD1, in order to reach CE2, there's 2 AS numbers in its path, and to a CE3, it has ALD2 and 65402. So again, it has 2 AS paths. So these are equally distant for ALD1, so it's just going to load balance traffic. Right? So it basically comes down to BGP best path algorithm. If the last 10 slides did not make any sense to you, I recommend go read through how the BGP path selection algorithm works, and all of this will make sense. All right, so getting started with SiteLink, a best way to do it is to use as a backup for your existing backbone. So if you already are using a backbone with Verizon, AT&T, any of those vendors, you can start by using SiteLink as a backup. Again, more BGP stuff here. In order to do that, what you can do is you can tag the routes which you're sending over AWS and over your backbone via different communities. And then as those routes are redistributed back to your data centers by AWS, we don't change those communities, we just pass them through. You can write a simple logic saying that if I'm getting routes using the green community, I'm going to not prefer them. So the preference here is 1,000. And the routes which I'm getting over my corporate backbone, I'm going to prefer them. Here the preference is 1050, the higher preference wins. Right? And if the corporate backbone somehow has a problem, then automatically your traffic can start routing over the AWS backbone. Eventually, if you decide to make your AWS global backbone primary, then you can change those rules. You can make the green have a higher local preference over blue. A lot of flexibility depending on how you want to achieve this. Okay, awesome. So it's time to summarize. What we saw today was how AWS becomes the center of your connectivity between your data centers. You can not only use Direct Connect to access resources inside AWS, you can also use Direct Connect Gateway and SiteLink to connect your corporate data centers globally. In summary, AWS Direct Connect SiteLink is also awesome. Right? So the vision has been achieved. AWS sits as a hub and enables connectivity from your data centers, branch offices, as well as your factories. Now, there's a lot of connectivity options we didn't discuss today. Primarily over the internet, we have VPN, client VPN, site-to-site VPN. Those connectivity options can also be used. Today, we were focusing more on Direct Connect and setting up direct circuits to AWS and using them to gain connectivity to AWS and between your data centers. Awesome. Thank you. Please complete the session survey. 5 stars is a good rating. Thank you very much.